Good day, ladies and gentlemen, esteemed colleagues and fellow software enthusiasts. My name is Seale Rapolai, also known as Seale. But don't let the nickname confuse you. I have never actually been a Navy SEAL, nor have I ever been one. I am, however, a software engineer, which is more or less the same thing, just with less muscles. And instead of putting our lives on the line, we put our fancy mechanical keyboards on the line. So I have come to you today to talk to you about software craftsmanship and my journey with it. In the early days of my career, there was a particular project that I worked on. The project was for an investment company whose name, unfortunately, I can't tell you, but we can call it Project Piggy Bank. So Project Piggy Bank was an investment company. They had a software where they allowed users to deposit money onto their platform, and then they would buy into various unit trusts and then manage it on their platform. As a junior, listening to my seniors explaining the software and how it worked, I felt motivated. It sounded cool and it sounded amazing, and I was hyped to work on the project. This was also mainly because my senior was one of those people that had the ability to make the most mundane and boring of things seem interesting and cool. So I wrote down a lot of notes, I drew a lot of diagrams, and we drew a bunch of data flows, and I learned a lot of jargon. I walked away from that knowledge sharing session feeling as though I was ready for anything the project could possibly throw at me. I was ready and I was hyped to jump and start working as soon as I could. But as soon as we opened up the software code to look at how everything that had been explained to me was actually implemented, I realized that I found it very difficult to map what I had learned from the knowledge sharing session to what was actually implemented in the software. It felt as though the more I read the code, the more confused I became. It was almost as if I was running around inside of a maze trying to find my way. It didn't take long for me to feel like maybe I should just run away, leave the project and find something else. But the funny thing is the software worked. It worked, so they kept on using it. They kept on adding more changes to it. So I decided to be brave, stay on the project and face the problems as they come. This was also because I figured maybe as time goes, I would get used to the project and it would get much easier. Before long, I was given my own ticket. The ticket was a bug fix on the UI. One of the components was misaligned, something like this. So I had to investigate why that was and fix it. So I jumped into the software. I looked around, navigated my way, avoided a lot of red flags, but eventually I found the problem. The problem was some negative margin that was applied onto the component's styling, which seemed pretty straightforward to fix. Just remove the negative margin and it'll be fixed. But as soon as I did, something else on the UI broke. And it was then that I realized that this supposed bug was actually a fix for another underlying problem. So I decided to be a good Samaritan and fix that underlying problem as well, which I did. But as soon as I did, the UI yet again broke somewhere else where I did not expect. It took a couple of hours going back and forth like this, finding underlying issues and fixing them, and the UI breaking, that I realized that I had stumbled upon a rabbit hole and I didn't know how far down it went. So hours later into the night, countless coffee mugs, I had to accept that at this point I had run out of time and the UI no longer looked like what it originally did. So I did what any reasonable software engineer in my shoes would do. I gave up. I threw in the towel and I had to accept that I can't fix all of these problems. So I did what I at that point realized was actually what every other software engineer that came before me did. I reached into my toolbox and I grabbed some duct tape, put it on top, and I called it fixed. It took a couple more issues on the project and tickets for me to actually realize that for the most part, the project was held together by duct tape and luck. It worked, so they kept on using it, they kept on adding changes, and they kept on going. I've since left the project. I've worked on many other projects, encountered many other challenges, but for the most part, what I've realized was that a lot of the problems that I faced on these projects were quite similar to the project that I just told you about. There was some software that was working and nobody understood why, but it was working, so they kept on adding changes to it and they kept on going with it. Ever since becoming a software craftsman, I've realized that many of the problems that we face as software engineers have a common cause. And that cause mostly lies between the screen and the chair. And as you may have guessed, I am referring to the keyboard. But on a serious note though, a lot of the problems that we face as software engineers are caused by us. Not intentionally, of course. It's either we did something without realizing the consequences or we simply did nothing. But this doesn't mean that we should get rid of all software engineers. We need software engineers in order to build software. They are indispensable to building good software. My career as a software engineer has been a fairly long one. I've been building software for about 7 years now. And in these 7 years, I've built websites, I've built mobile apps, I've built backend systems and even cloud infrastructure. And this was even before I knew what cloud was. And I've annoyed many of my colleagues by leaving hundreds of comments on their code reviews. In short, I am a full stack software engineer who runs around everywhere he can. But I see myself as more of a problem solver. And as a problem solver, my career has been more like a roller coaster ride than anything else. It has been filled with many ups and downs, but throughout these ups and downs, I have learned many lessons, some good, some interesting, and some cool lessons, and also some very painful lessons. But the biggest lesson of all that I learned was that working software is simply not enough. We need software built by craftsmen. So I've come in front of you today to hopefully share with you my dream of software craftsmanship, which has largely been influenced by my interests in science and technology, especially technologies such as the internet, social media, and mobile phones, which have had a very profound impact on the world and how it works. They've touched lives, they've changed lives, but some of these technologies are also just, well, quite cool. So I spend a lot of my time on the internet looking into these technologies, researching how they work, mostly because I enjoy learning how these technologies work. And I'm sure you're probably wondering what any of this has to do with software craftsmanship. Well, what I've realized ever since becoming a craftsman is that at their core, many of these technologies rely on well-written, robust code. Code that is written by software engineers. And for many of us around the world, we rely on software to manage our day-to-day lives. So a single disruption in any of these software can leave us feeling disconnected, unable to actually live our lives the way we usually do. Or even at times, feeling as though we've been thrown back into the Stone Ages. And software engineers are at the very center of most of this software and how it's built. They are indispensable to building good software. So regardless of where in the world you are, regardless of where you're watching it from, I'm sure you can identify at least one or two devices around you that have software on it. This can be anything from your laptop to your smartphone, your smart fridge or smart TV, or even smart lights. And everything else that doesn't have software on it has at some point been built, designed, or interacted with software. Software built by engineers such as myself and many of the people in the audience. Software engineers have in effect connected the world around us as we know it. And in the coming decades, we will write even more software than ever before. So I believe it is our responsibility as software engineers to not only see ourselves as people that build working software, but also as software craftsmen. So, how do you actually become a software craftsman? Well, the first step to being a software craftsman is a realization that most of the problems that we face are not caused by some mysterious force in the software development process, but rather in how we work. This diagram is a simple representation of how I used to work in the early days of my career. I got some requirement, maybe asked a question or two, then went off, wrote some code to implement the requirement. Then I would test the code, make sure that it did everything I expected it to, and then we would ship it and forget. Forget because despite what many may believe, we actually have lives outside of our jobs. So we forget so that we can focus on our hobbies, go outside, enjoy some fresh air, and get some much needed sleep. And I stayed faithful to this way of working for many years, in good times and in bad, in sickness and in health, until countless production issues did us part. But I have since found something even better, which is software craftsmanship, which, much like Agile, emphasizes how we work. And I'm sure many of you in the audience are quite familiar with Agile. So at one point or another, you may have seen the Agile Manifesto, which states the following. The manifesto for Agile software development. We are uncovering better ways for developing software by doing it and helping others to do it. Through this work, we have come to value individuals and interactions over processes and tools. Working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. But I'm sure if you have practiced Agile before, you may have also realized that Agile can be quite fragile. So from these 4 core principles of Agile, software craftsmanship was created, and it also has 4 core principles. The first one being not only working software, but also well-crafted software. With working software, we tell ourselves that as long as it works, we will ship it to production. But I've personally come to not like the saying so much so that the last person who said this, I almost punched them in the face. But I didn't, mostly because I didn't want to break my mirror. So we left it and we shipped it to production. We shipped it to production because it worked. It met the requirements. The client was happy. The team was happy. Everybody was celebrating. But if you are unlucky, like me sometimes, you get a call days later, hours or even minutes sometimes, and you're told there's a production issue. And immediately you're thrown right into the maze of code, trying to navigate your way and figure out where it broke, trying to figure out where it all went wrong. But if instead of simply working code, if we had well-crafted software, it would feel less like a maze, but more like a clear flow of code, like a well-designed highway. So, to put it like one of the founders of Agile, when it works, that's when the real work begins. So I would like to share with you a few tips that I have found quite useful in trying to build well-crafted software. The first tip is clean code. The idea behind clean code is to make your software as easy to read as possible. Because if it is easy to read, it'll be easy to change and it'll be easy to fix. So invest time in cleaning it up, making it easier for both yourself and other professionals to actually read through the code. Then the second tip is to make your software extensible and flexible. This will make it easier for you to add any new changes with as little effort as possible. And you can do this by applying principles such as try, don't repeat yourself, you state everything once or as limited number of times as you possibly can. And also KISS, which is keep it simple, stupid. And then the third tip for well-crafted software is introducing some form of automated tests into your software. By doing this, you give yourself the ability to verify that your software works the way you would expect it to at all times. So if you have automated tests on your project, you can trust that as long as the unit tests are passing, then your software is working the way you would expect it to. And then the fourth tip is to master the tools that you work with. As software engineers, we use a lot of tools on our day-to-day job. And if we haven't mastered the tools that we use, we end up spending more time trying to figure out how the tools actually work instead of working on the actual problems we face. But if instead we master these tools, then they will become transparent to the problems we face. Then the second principle for software craftsmanship is not only responding to change, but also steadily adding value. In responding to change, we tell ourselves that as long as business didn't log a requirement, then we don't have anything to do. It almost feels as if as long as the software works, then we will just not touch it. We will leave it as it is and just continue with our lives, simply waiting for the next requirement. And as I've said before, it is requirement, code, test, ship, and forget. So if there is no requirement, then there is no work to be done. And we simply spend time in between requirements waiting for the next requirement. But if instead we try to steadily add value, we would create our own requirements and add value through them. So here are a few tips on how we can steadily add value. The first tip is continuous refactoring. So by introducing refactoring as a way of working, you stop looking at the requirement in isolation, but instead you look at the requirement in the context of the project as a whole and aim to refactor the parts that are necessary to better accommodate the requirement you get. And in doing so, we will maintain a high quality of the software code. And then the second tip is to avoid technical debt. Technical debt is any enhancements or improvements or work on the project that we know will add value, but we simply haven't gotten around to actually doing it. So if we don't actually tackle the technical debt, it ends up weighing us down. It ends up being something that holds us back from actually doing more with the software. So if your project has technical debt, prioritize getting rid of it as quickly as you can. And then the third tip for steadily adding value is to establish some form of standards, an agreement between the engineers for how you will work. By establishing standards, you will have some form to verify and validate that everything or every change that you add into the software is of an agreed upon quality. So by simply working and referencing the standards, your software will be better. And then the fourth tip for steadily adding value is software monitoring. Software monitoring allows us to monitor our software and how it is performing. This can be anything from bug tracking to performance matrix or anything else. But as long as we can gain some information and insights on our software, then we can use that information to better get ideas on how to improve our software. And then the third principle for software craftsmanship is not only individuals and interactions, but also building a community of professionals. With individuals and interactions, we tell ourselves a lot of the time that we can figure out most of the problems that we face as long as we're given more time. But what I have realized is that as a software engineer, there are many things that can trip us up. This can be anything from deadlines to bugs, confusing requirements, legacy code, or a lack of coffee. Or sometimes it simply works on your machine and nowhere else. So if we instead try to isolate ourselves on some remote island and figure out most of these issues on our own, and only see talking to other professionals as individual interactions and individuals, then we eventually run out of time and we are forced to run back to our teams trying to explain why we don't have a solution. But what I've come to understand is that great software is built by teams and not individuals. So rather invest in building a community of professionals. So here are a few tips that I believe will help in building a community of professionals. The first tip being documentation. So document anything on the project that is important. This will make it easier for us to share information and knowledge between professionals. If it is important, then it should be documented. And this can be anything from configs to how to set up the project, how to run it, or any explanation for why certain things were done a particular way on the project. And then the second tip for building a community of professionals is investing in building relationships with the other professionals. Many of the professionals that we work with have a variety of experiences and knowledge. So in building relationships with them, we can learn from them and grow together as teams. So invest in building good relationships with the professionals around you. And then the third tip for building a community of professionals is contributing to open source. Many of the projects and tools and even a lot of the knowledge that we have as software engineers comes from the open source community. So in investing back into the open source community, we grow our community of engineers as a whole. And we can do this in any number of ways. We can do it by tackling issues on one of the projects that we're using. We can do it by answering questions on platforms such as Stack Overflow or GitHub issues. And we can also do it by writing blog posts to share our knowledge or even giving talks at conferences like Escape. Then the fourth principle for software craftsmanship is not only customer collaboration, but also productive partnerships. Customer collaboration tells us that the customer is always right. But sometimes the customer doesn't know what they want. They tell us that they want X, so we run off to the drawing board, we do some planning, we write some code, and we deliver X. And then they come back the next day and tell us, no, this is not what we actually wanted. We want Y instead. So we run back to the drawing board, do some planning, write some code, and we deliver Y. And they still come back the next day unsatisfied. And this can be extremely frustrating. At some point, we feel like just grabbing the planning board and then just smashing it on their heads. And depending on the type of project you're on, as a software engineer, you may be even fortunate enough to be abstracted away from the customer by other professionals such as UX designers and business analysts. So much so that we may not even know who the customer is anymore. And I understand that this can actually streamline the software development process, but it also bears the risk of abstracting the engineer too far away from the customer and losing their ability to verify that the solutions they've built have actually met the customer requirements. So instead of simply customer collaboration, we should look at it as productive partnerships and aim to interact with not only the customer, but the other professionals around it and business that understand both the user and the business requirement. So here are a few tips on how we can build productive partnerships. So the first tip is stakeholder and customer relations. This involves building relationships on trust and transparency, making it easier for us to verify that the solutions we have built actually solve the problems we aimed to solve. Then the second tip is user analytics. This involves adding some form of monitoring on our software to track how users and customers use our software. And by doing this, we can use this information to find ideas on how we can better improve our software. Software craftsmanship is meant to be a solution to many of the problems that we face as software engineers, especially even with processes such as Agile. It is a skilled, deliberate, and thoughtful practice. If you scan the QR code on the screen now, this will take you to the Software Craftsmanship Manifesto, which is a summary of everything that I have just told you about, which states, as aspiring software craftsmen, we are raising the bar to professional software craftsmanship by practicing it and helping others to learn the craft. Through this work, we have come to value not only working software, but also well-crafted software. Not only responding to change, but also steadily adding value. And not only individuals and interactions, but also a community of professionals. And not only customer collaboration, but also productive partnerships. That is, in pursuit of the items on the left, we have found that the items on the right to be indispensable. If you would like to learn more about software craftsmanship, here are two of the books that I would personally highly recommend. If not, you can also follow these authors on YouTube or on Twitter. But the idea is, if you want to learn more about software craftsmanship, there are resources available online. So you should go out there, explore it yourself. Building software can be an extremely difficult task. For the most part, it feels as though you are jumping into the unknown and trying to figure out where anything goes. So to all the software engineers out there who are able to get up every single morning and still build something that works and release it out into the world, that to me deserves my utmost respect. But working software is simply not enough. We need software built by craftsmen. And it is only by building software as craftsmen that we can elevate our work into true works of art. Thank you.